Today's conversation is with Michael Heltzen, the CEO of eXoZymes. Michael is a seasoned business professional with over 20 years of experience in leading startups and established businesses in the biotech space. Today's conversation revolves around who eXoZymes are as a company, their core mission and vision, as well as key concepts related to the industry in which they operate. This video is supplementary to my extensive eXoZymes report, which I released over on my Substack, and I'll provide a link to the report in the description below. Enjoy the conversation.
A short introduction of myself. I'm Michael Heltzen, the CEO of the company. I was born and raised back in Denmark, hence my accent. I have a background of basically having built a couple of companies before in that cross space between computational power on the one side and molecular biology on the other side, and the new use cases that comes from combining those areas. As a brief overview of eXoZymes, we basically build biosolutions. That means the capability of biomanufacturing things that are chemicals that are typically something we find out in nature, and then we have to isolate it. And when we humankind figured out back many years ago that there was such a thing as oil, and we with petrochemicals could start basically building all the chemicals and you can argue the good life that we're living in the modern era. We kind of had those two as the fundamental ways of getting access to chemicals. What we do differently is that we try to take the best of those both worlds and basically leave behind the limitations of those two things. On the natural side, the limitations have been, frankly, that there's too little to go around, so you can't make it in the volumes so everybody can get it. But it's sustainable. On the other side, petrochemicals, you can very easily scale that up, but it's not sustainable. It's actually often either toxic or polluting or other challenges there. So the best of both worlds approach would, of course, be if you had the grandiose diversity that biology represents, and if you had engineering control level that petrochemical allows for, so that we can get things up at mega scales. And also, to be fair to nature, it's actually very innovative. Like evolution is really, really good at making new chemicals exactly where it's needed. It's much, much harder for us to kind of do that over in the petrochemical world. So at its core, we built biosolutions that has the best of both worlds, and we do that with eXoZymes that we'll dive into a little bit here.
Awesome. Thanks, Michael. So before we go into eXoZymes, I'd love to paint a picture of yourself and, your prior history in the biotech space. So could you please detail some of your previous roles in the industry?
Yeah, absolutely. So biotech is not a word people typically think too much about, but it's actually biotech and tech bio that is kind of the professional language of the space I'm in. So we end up saying tech bio because people have already run away with the word biotech. Biotech, people think about drug development, but it's actually biological technologies. That's why we, if that word had been free, if that had not been occupied territory, then the kind of technology I belong to would probably have called ourselves biological technologies. It is a fundamental belief in that technology is biology and biology is technology, if you really think about it. Obviously, it's said with a smile. We don't look for the USB port in the tomato, nor do we go out and claim that we can fully code life. But there is a really, really intriguing level of that DNA codes for RNAs that forms and gives life via proteins to keep it really short. And what we probably have termed tech bio is us, the kind of entrepreneurial people that are intrigued about the next generation of tools we can build so that we can use biology as technology and allow us to build things that otherwise could be built. And my professional history was basically started 20 years ago back in Denmark, where we were some startup guys that built a company called CLC Bio. there was a bioinformatics company. So basically, what could we do with computational power to figure out what the DNA that could be sequenced much slower, much more expensive, less quality, at least in some perspectives, compared to today. But what could we do with DNA knowledge over to what does that mean? What can we do with that? So we built a bioinformatics company, and we went really well and became one of the world's largest, at least from a commercial point of view, bioinformatics companies. And we sold that to QIAGEN, and it's a part of what is called QIAGEN Bioinformatics today. So software programs that are used by a lot of people in the genomics, genetics, transcriptomics and proteomics spaces. But it was really in the next generation sequencing analysis space specifically that we had a big breakthrough in regards to development and deployment of those kind of technologies. That led me to a career where I got invited in a number of projects, companies, startups around the world. And today is too short for us to go through the whole list of things that I've been lucky to be a part of. But just to mention some of them, I was one of the guys running one of the early human genome projects, genome project number 8 to 10, from the point of view of sequencing a human to find out from a perspective of the specific starting point was the Arab human genome. So we, the human race, we wandered out of Africa, and that Arab Peninsula, we split up and became all the good types of humans we are today. And therefore, from a population genetics point of view, it's a very, very interesting kind of like genetic data set. So ran one of those programs back in 2007 when we were talking about millions of dollars per human genome, and every single tool used per genome was custom built to that specific data set person, depending on how we think about it. It let me go on to the next companies that I've been co-founding. That is basically always been in this biotech, tech, biospace, where how do we take the newest of new technology and allow for a new type of measurement that allows for a new type of, for example, calculation or insight that allows for new application. So we started already in the first startup that I talked about already to use machine learning and pattern recognition. So how can you basically use patterns in data to foresee something or guess something or know something, or maybe even better, if it's a circular training circuit, how do you, by using and generating data, get to the next level that then can generate data that gets to the next level, that gets to the next level. And fast forwarding to eXoZymes, that is what we do here. We basically use very advanced bioengineering to optimize enzymes, to push them to a new generation, where we then record data on them real quick to train an algorithm to guess how to take it to the next level. And we run that circle that you can think of as evolution, but we're just massively speeding it up so we can kind of, in popular terms, run 1,000,000 years of evolution over the weekend. So it gives us some capabilities to build and push enzymes into states they maybe not would have gone to naturally, but would have taken millions of years. And we can, from that perspective, start having enzymes that can do things that they typically don't do. What is an enzyme is the next level of that question, of course. Well, that's where we get all excited about eXoZymes and so on. We'll save that for a bit later, but who am I as a person? I'm an entrepreneurial strategist, visionary, business executive that also, as much as I talk and I dream, I like making things happen for real, because otherwise it doesn't matter in my world. And having executional focus and power is one of the things I bring to it.
Yeah, so it seems like you've been involved quite early on with some pretty significant and globally impactful platforms. So all this knowledge and information that you've gained in the past has led you to the wonderful role as the CEO of eXoZymes, and that's very exciting. So along this journey, you would have witnessed a lot of tech, bio, and biotech ideas, some which were obviously quite successful. So, each company would have provided valuable lessons to yourself, the companies that you're involved in, but also the companies in a broad sense within the market as they go to launch their platforms. So you would have seen kind of what works and what doesn't work and take little snippets of each. So then prior to joining eXoZymes, you would have gone over the claims of the company and, filtered it through your experience and your own knowledge. So what was this vetting process like for yourself prior to stepping in as the CEO of the company?
Yeah, the first time I heard about this grand idea of taking what happens inside of a cell, the enzyme pathways that makes the chemicals that I was talking about, that somebody had figured out how to run them outside of the cell. It was so mind-puzzling that I basically dismissed it. I was just like, there's no freaking way that's not possible. Everything I know contradicts that. And not that I'm a super knowledgeable kind of scientist, but I've done nothing else the last 20 years. I'm kind of trying to find the newest new and so on. And I just have to eat that. The guys figured it out. And it was actually kind of as easy as sitting down and reading some of their Nature publications and getting up here and kicking the tires of it. It doesn't really matter if I understand every single detail of it, because it's so evident that it works. The same way I would argue that my cell phone, there's no way I can prove to myself that it actually works other than it works. And therefore I can call and I can do all of the amazing things. So I'm pretty sure it is, for example, you, James, sitting on the other side of this call and so forth, because I have a reality check opportunity via other channels. So it is even what the co-founders, the technical co-founders themselves are saying, like it was almost too good to be true when it was there. So they actually kind of were challenged by trusting the data. It's not easy though. It's not we're lucky and then from there it was a golden goose that just kept laying eggs. It was more of a blip in a data set. I was like, did that really just happen? How can we make that happen in a stable manufacturing way? And it's taken a decade for the guys to really, really dig in. So that's the second part of why it's relatively easy for me to do my due diligence that I otherwise pride myself for doing, both on a technical side, sometimes by buddies of mine that have the really, really deep technical insight that also looked at this. To be honest, they looked at it anyway, but didn't really have to in this case. And then the kind of, how does that fit with the world we live in today? How does that fit with the business opportunities? Because it doesn't help if the business opportunities is in 10 years from now. It has to be something that can be applied now for it to have my interest, at least in the moment. It's very evident when you start digging into these things that we are solving problems that are kind of otherwise unsolvable. We're producing things that are otherwise not possible. And that's all. That's kind of enough for me to start building with that. Then there's the extra layers of what we can do in the future when we get more and more sophisticated with the platform. But let's talk about that a little later.
Yeah, and what I recommend listeners to do is head over to my company report on Slack Capital, and you can find more layman's terms of these scientific concepts that Michael's talking about, in addition to the scientific reports that eXoZymes has released previously. And reading over them is quite impactful, and it provides a really clear picture of what eXoZymes has achieved in the past and also what they can achieve. So then let's dive a bit more into eXoZymes' platform. So can you detail what the platform accomplishes, produces, and also this impact it has on its commercial partners?
So if we take the conversation first from a short-term perspective, what is it we do here now? And then afterwards we can have the same conversation, but just from a let's dare to dream and talk about like real long-term perspectives. Those are obviously two different things. Short-term, we built biosolutions that allows us to make, for example, nutraceuticals and pharmaceuticals that are inspired by natural products, something that's happened out in nature, but you would deplete the world's resource of it if you try to put that molecule that maybe is already proven as a nutraceutical or as a pharmaceutical, or as the potential of a pharmaceutical. But if you want enough to talk about being a treatment, then you deplete the world resources within a year, and you would basically have cut down the tree you're sitting in, so to say. And those small molecules, those medicinal compounds that people have found in nature, but we can't make them, even if our life depends on it, are the ones we like to go in and say, what are the enzymes inside of that bark cell or that root cell, or wherever this pathway of enzymes that takes basically often like sugars or other readily available things and breaks it down in very, very small, tiny compounds or small bits and pieces of chemicals. And then other enzymes builds them back up into the exact molecule, the exact chemical that is needed to, in the conversation we're having here, to be a medicine. But for the tree or the plant or wherever this enzymatic pathway lives in nature, plays some other role. And we're in a very unique position to study that innovation that have happened in nature, and then take that out and recreate those enzymes. First, the pathway itself, and then we can start optimizing on the enzymes so we can get it to also make new versions of the natural product that is made even better, either from a feature point of view or from a cost point of view or from a stability point of view or whatever the market is really looking for. And we seem to be the only people in the world that is come this far in the history of building enzymes that can kind of take us to the next generation of what in traditional chemistry is called small molecules. That is something, you can build many small molecules with basic petrochemical or medicinal chemistry, but there is a very large limitation on places you have not been able to go before, where we can now walk into that new small molecule chemical space and start building molecules. So that has a lot of people's interest, and from a commercial point of view, that's what we're pursuing first.
Yeah, and so as you alluded to at the start, this is more the short-term vision which the platform can achieve and, the company wants to see through. So then a counter to that, what's the more longer-term future vision in which you see for eXoZymes?
So the reason why there is a difference is because if you try to do everything a broad platform like ours can do, I keep calling it like that. That would be the equivalent to trying to boil the ocean. There's no way you're going to do that. So having a focused strategy that allows us to take where the platform is now, what we can already do, and know we're really good at making new versions of, and how that applies into a specific market vertical, we can become really good at doing over and over again with different partners in slightly different market segments. That's why there's a short-term focus. Longer term, you can argue, is the potential. Longer term, this is frankly a new way of making chemicals for humankind that is, if you think about it, like a new natural resource, a new way of ensuring the future will be bright if you like really zoom out, because we're not going to have the limitations and the toxicity pollution problems of petrochemicals that we otherwise probably strangle ourselves in, which is obviously a problem. And there will not be enough if we were just to rely on what we can harvest in nature. So presenting a third generation of access to chemicals for humankind, that is actually the balance point. That's a really good question. That means we can branch out a lot of other things than nutraceuticals with pharmaceutical potentials. We can go into industrial chemicals, we can go into fragrances, colors, and like all the different kind of chemicals that are out there. And the way we have chosen, by the way, that's always the next question I get. It's basically as simple as we are a new platform, so we start where there's relatively low volumes, high value per compound we make, because it's just easier to make business on without having to build huge facilities. But of course, it doesn't mean that we have missed the fact that there is some really, really big potentials to take care of some of the extremely large industries that really truly are the polluters of the world, and therefore something we need to address as humankind. And we have been so lucky that, not just lucky, but also the reason why our focus strategy is literally called nutraceuticals with pharmaceuticals potential and extraordinary business cases. That last part, extraordinary business cases, is, for example, when the US government, via the Department of Energy, walks in and goes like, you guys can make basically compounds that can't be made with normal synbio, that have been a big investment area that have unfortunately have very little to show for it. And they have spent so many $1 billion on trying to get biofuels, and they started realizing that if you synbio way kind of try to make cells make biofuels so you can ferment your way to it, then you run into that other than ethanol that cells are relatively good at making. And we humankind have taken advantage of for 1,000 years at least. All the other kind of fuels, for example, aviation fuel, is chemicals that are so energy rich that they're toxic for the cell. And therefore you kind of end up, if you try to get the cell to make sustainable aviation fuel, you end up killing the cell, you end up with all of these problems. And they looked at us and went like, you guys are cell free. You don't use cells. These are just enzymes. They're not alive. It's just a protein that kind of makes a reaction happen, but there's no living matter there. So it looks much more like chemistry, but has all the advantages of biology. And they were kind of like, would you mind taking basically a go at sustainable aviation fuel via the compound that it's called isobutanol. So isobutanol is our extraordinary business case that we are working on and have been working on and have shown really nice results on already now. But it's a long development cycle where just because you can make something in just because you produce 10 times as much as you did last year, if you produced 1/100th of a drop last year, then you are just still at 1/10th of a drop this year, and next year you will be at a drop. I'm not saying we are at drop scale. We are actually at significantly higher scales, but we are working our way up through that exponential growth curve that is needed for a very large industry like the aviation fuel industry to be replaced with sustainable aviation fuel, because we're talking about supertanker after supertanker after supertanker kind of size before that is really making an impact, where we have pharmaceutical use cases where a kilo of end product is literally the world market per year. And it's obviously just much easier for us to reach that level and make commercial business on.
Yeah, so you've mentioned the significant benefits that eXoZymes platform has compared to existing chemical manufacturing methods in the industry. So, to paint a picture, can you provide, an overview of the chemical manufacturing industry as it stands today?
Yep. Well, plant-based is pretty simple. If it's a compound there's too little of nature and you can't just grow more of it, then you have a problem. If there's then a problem on top of that isolating that 1,000th or 1/10th of a thousand that the chemical might be of that root, then that might break your business right there. So that's kind of like, in really rough terms, the challenges with natural products and harvesting chemicals from nature. Then the other end of the scale that is us taking oil up and breaking that down with biochemistry is something that has served the world really well. And as much as it's a problem, we should not forget to be grateful for the lives it's given us and the progress it's given us. We would not have semiconductors. We would not have the living standards. We would not have all of these things if it wasn't because of it. But we have to see it as a gear where it was good in the acceleration phase, but it's not the long-term solution if we dare to think 100 or 1,000 years out in the future. And that was where SynBio came in with a very similar, if you won't argue, it's the same vision as we're living and dreaming by, that could we make cells the chemical factories, and we could engineer them and be in control of them, then we would basically have taken the best of both worlds. I just think people should have taken a deep breath and thought about controlling nature, how easy that sounds, how often we have managed to do that. Try to go out and hold back a wave out close to the Pacific here, right? Like it's not as straightforward as it maybe sounds on a piece of paper. And we ended up with SynBio being super, super excited about being able to genetically engineer cells and make them make a little bit of chemical. But where we kind of forgot to ask the host, so to say, what kind of party we could have, was that the cell does not want to do anything it doesn't benefit from, because that's literally evolution 101. That's how you get on in life if you are a cell. And therefore, when we turned on the production of some chemicals the cell doesn't benefit from, we just went in and turned it off relatively quick. So you basically have built yourself a chemical factory that auto shuts down all the time. And that's not good for business, obviously. The next layer is that and it's not just a simple shut off. There's many mechanisms to optimize what is going on in a cell. So it's not just one button you go up to and tape it on, and then you have fixed it. And this is where SynBio got called for a decade, and there is today. And I truly hope that it will succeed more than it succeeds, because we need many solutions for the future. But there's not a lot of success that have come from SynBio. The next layer is that the cell itself can actually be sick or die from the chemicals we make them. So that's to continue this picture. That's the equivalent to like you're making a chemical in a factory where the chemical makes the factory burn down. Good luck making a business out of that. Next layer of this explanation of why SynBio is challenged is that, okay, fair game. Let's say we solve the two first ones. We actually get it to keep producing, and we make it from burning down, so to say. Then you have a factory where the product doesn't come in. It's not like you're giving feedstock in the one side and product comes out in the other side. You walk into a factory and product that is maybe very, very little bit of the whole factory is now built into the walls, it's built into the floors, it's scattered all over the place. So your isolation cost of getting to your end compound this way is often higher than the value of the compound. How are you going to make business out of that Excel sheet if your cost of isolation is higher than the value of what you're isolating? It doesn't take a lot of math to figure out. That's why a lot of the SynBio companies are now basically on the graveyard. From a financial point of view, it would never make sense when you can't isolate it. And this is the story that people have, unfortunately, because it is a little sad, has spent billions and billions of dollars. It was so easy to raise money in that space because you could come out with a petri dish and see, I'm making this compound, it's worth so and so much. Imagine a future where we had the cells do that at mega scale, but it never scaled. So that's a fundamental challenge that our technical co-founder team here, when they sat down, cell-based, and made a publication, and they were all excited about it. They also afterwards looked at each other and went like, but guys, this is never going to be real. This is never going to happen for real, because the cell will never allow us, the financial model behind this will never make sense. And they wanted to make impact. So that's where this famous moment that we've described a couple of times is where Jim Bowie, basically the PI in the lab, says to the two PhD students, okay, build the pathway without the cell. Have a good day. And let's just retire the cell. And we still don't know exactly how many percentage that was a joke and how many percentage that was a genius idea. And as Tyler describes it and Paul describes it, it was kind of like they were young and naive enough to give it a shot. It's like, who says we can't walk on water if we're just running fast enough, like entrepreneurial style? And there's some truth to that. So that was where the journey started. What does it actually take for us to have these enzymes that are the enzymatic pathways, production pathways inside of the cell, live outside of the cell? And most people will say, well, that's not possible because there's all the cell support systems that makes the pathways able to run. And they sat down and said, like, okay, it's down to fundamentals. What are those systems actually? How can we recreate them or something similar outside of the cell? What is it that makes everybody go, like, if you take an enzyme and you take it outside of the cell, it will basically stop working on you? And there were proofs already, back to actually Denmark, NovoZymes and other companies that have been leaders in the world of taking one enzyme from somewhere in nature and then making it in a version that works outside of the cell. So, for example, most likely in your detergents, there will be one or a few enzymes that are from NovoZymes that has been probably spent tens of years and at least tens of millions, if not more, on optimizing that one enzyme to break down fat or soil or blood so that you don't have to use as much heat in your washing detergent. You have an enzyme that goes in and makes that chemical reaction happen faster than where before you were basically heating it up for that chemical reaction or want to break. And so there was evidence in that you could make enzymes live outside of the cell. So EXoZymes. And that's why these guys sat down and said, like, what if we just recreate it? We build all of these support systems, figure out all the energy co-factor balances and so on, which is like already here. Most people with a PhD, they will start throwing rotten tomatoes at you and say, like, this, you can't take on all of those things at the same time. But again, the oomph of not knowing the ability to just run past problems and sometimes through walls is basically what brought them to a state where it started work. And then, of course, figuring out when it works one time, why does it work in this case? How can you go back, change the system, take it up to a new version? Now it works on more things. It works on the same thing, but better. And basically having worked on the platform until it was then spun out from university in 2019. And those academic realizations that was captured in some patents that was licensed over in the company then became like, okay, now it's actually more about doing it, but doing it on commercial scales. How do we do these things? So that's the core of the company. And then what Tyler and Paul and the teams here hadn't spent a lot of time on before I came and I looked at it and I started kicking the wheels, was using computational power, machine learning and AI style. And it was pretty evident to me by just looking at it that here were guys that had so much knowledge and so much data on how to optimize enzymes over to what we have now named eXoZymes. So basically enzymes that live outside of the cells and fits into these much more human designed parameters, because we know exactly what kind of bioreactor, under what heat, under what pH, and so on. So we control the environment that the cell otherwise took care of controlling, so we can biomanufacture with it. And I was looking at a team that just had an enormous amount of knowledge and an enormous amount of data, and could, by talking to each other, pattern recognize. Every time that becomes obvious to me, I go like, that's a computer that should be doing that. We shouldn't be doing that. To pay credit where it's due, it was a number of our younger scientists in the team that when we started talking about this, saying like, yeah, we've already been using, of course, like these guys were using computational power to all the tools available. But that whole idea of, can we sit down and use computational power to foresee what genetic mutation leads to a feature change up in the enzyme? And you can argue that's what we've been doing, but very much in conversation and one-offs. That was where Emily from our team went in and was kind of like, there are these new tools coming out and algorithms coming out, and especially if you set them up right, then we can start producing a lot of guesses. So tens, hundreds of guesses on what are the mutations. But at the same time, there was a little bit like, okay, but what is that going to help us? Because before we sat down, everybody put our heads together and said like, okay, what is the best mutation? What is maybe the 3, 5, 10 best mutations? Because we need to go out in the lab. I don't know if you can see the lab out there, but like we need to go out in the lab and literally insert that DNA into, for example, in E. coli, have that express the enzyme, and then see if it was actually better. That feedback loop was relatively slow and was a lot of work and was costly, therefore. And then and another couple of people from our team, Bastian specifically, was like, hey, I actually have a sense of how we can, if we have so many guesses, how we can brute force that whole thing with basically liquid handling robotics. And then we started talking about how can we speed up the circle from when we have a guess on something that is better, how can we get that to actually happen by an enzyme? How can we record data on that enzyme, feed it back in? Because now you have the circular training loop that for anyone that is nerdy about machine learning, as I am, will go like, instead of just having a data set and then you have to save some of your data to train a model over here, and then you can predict over on what you output, you kind of run out of data. If you can come to a point where the solution itself generates data, this is the self-driving cars kind of setup where every time someone is driving, let's say a Tesla or another self-driving car, then you actually generate data. And it's not so much when you drive a perfect route on a place where people have been before. It's actually more if you drive a place where nobody have been before, or if you have, as brutal as it sounds, when you do something wrong, when you literally hit the wall, then that's a good training data on not to do that again. And with that picture in mind, it's actually how I can explain how we benefit from, as the first company, to take not just our machine learning to what could be better, but learning from when it goes wrong. So we can actually celebrate equally much when we make a prediction, we're supposed to do this thing, and then it doesn't do it. Because then we know we need to go back and train the algorithm to know not to hit that wall. So this is where AI and machine learning really takes enzyme evolution to the next level. And we're just passionate, nerdy, and business-oriented in that specific vertical. So this is back to, is it biotech? Is it tech bio? It's a little bit of both. It's both the new technologies and then making applications. So it allows us to make drugs of very, very specific things that otherwise could not be made by petrochemical enough.
Yeah, thanks so much for the extensive details that you've gone into. That's provided a really good picture of the current space. There's so much to go off there, but I firstly want to recognize the SynBio and cell-based, how it's simply struggled with the fact that it can't economically scale. And as unfortunate as that is, it also highlights, how monumental eXoZymes platform is, given the fact that it doesn't experience these inherent issues. And to that point of, the integration of modern tools, I'm really excited to be talking with Tyler Corman, the VP of Research at eXoZymes. And we'll be discussing, the tools and the integrations of these systems into the company's platform in the next interview episode. So I encourage everyone to listen to that episode when it comes out as well. So you mentioned that eXoZymes, your platform can allow enzymes and the biocatalysis process to occur outside a cell. So is your company the first one to achieve these results in the space?
We stand on the shoulder of giants. So don't get me wrong when I say we're the only one. We stand on the shoulder of giants. There's, amongst other, the type of ingredients and building blocks we're building with is 4 of the latest Nobel Prizes in chemistry. We use those technologies. And at the same time, when that's said, I think Jim, Paul, and Tyler, they just decided to swim against stream when everybody was going with the stream because there was so much money in SynBio. And they just had a clear vision on like, it would never scale. And if it doesn't scale, why is it going to matter other than academically for research papers? But that's not what they wanted to do with that. And they didn't want to just raise money for the sake of raising money when they knew the money would be spent on something that wouldn't work. So I think that's why we are in the lead position we are today. There is a combination of technologies. So we are the leader in enzyme optimization, especially in this eXoZyme direction, because no one else has have sat down and said like, hey, this thing about having enzymes that is outside of the cell, instead of just doing one or a few, doing maybe even tens, but at least 5, 10, that's just been considered kind of like too costly, take too long. Why would you even do it? Because people didn't dare to dream it all the way through as these guys. They dared to from the beginning and say like, well, it's SynBio's just generation 2, where we don't have all the things that is not going to make the first generation work. And it's fundamentally a drive that I also frankly screened the company for. I know your question was also like, what did you do to screen the technology? The reason that I do things is because I want to see the impact on the world, and therefore, as provocative as it can sound, and it's really not meant as it. Technology is maximum a third of that equation of it's going to happen for real. So it's the technology. Is it the right time for that technology? Is it the right team? Very, very, very often it's not, and it's unfortunately very easy for one person to screw up a team of 30 people. So it's really a high bar. It's not just like in average it's a good team, or it's most of the people are good. It's literally like, is everybody set up to be the best versions of themselves in that moment and pulling in the same direction? And let's just say I saw an A+ technology opportunity, but an A++ team opportunity in this team. So that was really why I joined. And I think it's really important to remember that when we start talking about the ability to turn this kind of technology into reality and business opportunities, that's the consequence of those realities. Because it can fail many ways, and it's never 100% according to plan. I do belong to the younger generation of entrepreneurs that basically says like, if you ask a written business plan and you sit down and you spell it all out, by the second that is done, reality have already gone to the next page and you're now behind. And maybe it's the only thing you get, and don't get me wrong with what I said, like the only thing you get from a business plan is that you agree on your assumptions and your beliefs in that moment. But I guarantee you, if you write it down, it's not going to happen that way. It's almost like defiant that way. But at least you now have the chance to have a fixed starting point where everybody's on the same page. And then every time, if you have a team that is good at communicating, can communicate back when they've realized something is different than the assumption, and dares to, based on trust, come and say, hey, what I was advocating for before is actually wrong, because it's often the experts in the area that has to realize they're wrong. Therefore, you have to have a culture where finding something, it's not going to be about blame and shame and like, why did you say that before? But more so like, okay, that's great. How do we calibrate really quick to take advantage of that opportunity? Because if there's a shadow and shade, there's sun somewhere. So it's just a matter about getting out of the darkness and getting over to where the sun is. And that's much more about teams and how you create cultures and how you make individuals be the best versions of themselves. So that's equally important as the whole technology aspect.
Yeah, and having the right team is such a significant point. And I've been really impressed to see the caliber of individuals that eXoZymes has accumulated at the company. And I recommend that listeners head over to my report to go and read, those key business executives that are working amongst eXoZymes. And it's really exciting to see, their past experience and the deals that they were able to achieve, and now all bringing that together into eXoZymes and launching it into the future. And, you've previously mentioned as well, the company has collected some of the world's best scientists in their respective fields. who are working to build and facilitate the development of eXoZymes platform. And, you know, when you have a team working like that with the synergistic energy and really seeing and wanting to usher in a vision of the future, it's a very exciting and very collaborative place to work within. You know, so further beyond your company, eXoZymes also has quite a few partnerships, you know, with MDB Capital, with the DOE's NREL division as part of Shell's Game Changer program. So how do these relationships work to expedite eXoZymes platform going forward?
Yeah, so let's start in meta language. It takes a village to raise one of these opportunities. So we recognize that we come with technology, biosolutions that represents a competitive advantage into a specific market, and especially when we find a partner that can help us utilize the opportunity from a business perspective, then that's definitely a great partnership. So that's overall. It takes a lot of different people in partnerships in the individual application space, in the opportunity to to take the platform to the next level. We are using technologies that we buy a license in, so we don't have to build everything ourselves. There are different kind of partners you need at different level and stages and for different things. And very specifically, MDB Capital have been the very unique capital provider and capital access point provider in the journey of eXoZymes Incorporated, by basically daring to be a investment bank that sat down and said, we will look for what they call big ideas, where it's like so fundamentally different that it's going to change the world if it's really true, if it can really work. And there's very skilled team of researchers, market researchers, found basically this business opportunity after it had just started as a startup, and was still halfway in academia, because licensing wise it was about to be spun out, and they dared to take a bet on a green banana, despite that is something that is very, very scary for most investors. But sat down and said, okay, there is an opportunity here. If that's really real, then we want to be a part of that journey. And with the support of MDB Capital, we IPO'd last year, because that is the very unique thing they provide. It's not just a cash investment, as, for example, a VC would do it. They come in and say, forget about the typical VC terms and all the stack preferences and all of these things. That is why I have gray hair, despite just being in the middle of my 40s, because that's how my life has been before. And it's really truly one of the hardest thing of building other companies, is to navigate that whole reality that money is just needed to survive, and at the same time it is what's going to make your life so much harder that you take VC money. And MDB Capital comes in and says, like, we want to be co-founders. We basically will take common stock. There will be no special preferences on the ownership, and we will basically lift you forward to an early stage IPO. We'll make you ready to communicate your vision so that you can go out, and they helped. That it was the MDB community that spotted me and my potential fit over to eXoZymes Incorporated, and from that perspective have brought a lot of the different things to the table. And via a roadshow last year, we were one of the very, very few successful biotech IPOs last year on NASDAQ. That is how we have raised money to go and really commercially start building and scaling up to to the larger potential.
Yeah, and also MDB's backing has been quite monumental for the company. So they helped form the company structure as well as provided the necessary resources to get the company to market. And one of the last interviews that I'll be releasing as part of this interview series will be with Chris Marlett, who's the CEO of MDB Capital, and he's also the chairman of eXoZymes. And we'll be discussing MDB's vetting process on the company when they first discovered. And I think this will add further validation to eXoZymes' platform and the achievements that the company is making. And so before you mentioned that SynBio and biotech companies often need tens of millions or hundreds of millions of dollars to get their platform to market. So last year in November, eXoZymes raised $15 million in their NASDAQ IPO listing. Can you speak to why this amount was raised?
It is near impossible to do cell-based SynBio, as the track record of the industry basically shows. Where the kind of biosolutions we're building, a lot of the cost is building things that didn't exist before you get to and that journey was done academically, and then was done based on since 2019 based primarily on grants. So there's more than 2 times as many dollars gone into this company from non-dilutive grants as investment dollars before the IPO, up until the IPO, and that have allowed for a new platform that basically engineers around all the problems that could be observed publicly, and then also with a focused strategy, we're focused on something where it's everything equal is relatively close and easy to perform on. And then just also working on sustainable aviation fuel, but that's not going to be done very soon because it's such a humongous task to scale it up. The scaling up is typically also what costs. Put your number on it, but like when people hear about hundreds of millions of dollars in scale-up cost, that can be divided between actually still in the ground, kind of it just costs a lot if it's a very, very large operation. But then also with SynBio, you had this challenge of you had a chemical production platform in a cell that kept getting sick on you. Then having to go back and like what is now wrong with it. So remember, it's cell-based is literally a living organism. It can get sick any way that nature allows for something to go wrong, and that is not a limited space of outcomes. So that's why there has been so much engineering going into it. Why it typically takes years and tens of millions of dollars, where we are lucky because the platform has now been built and there's no living element in it. It's more about us sitting down and picking the right application areas where we are relatively close because we have already built the eXoZymes, we have already proven the different modules. So it's more about combining modules we have already and developing a few new modules, and then we have a new product. And the scaling up, I'm not making it smaller than it is. We are also facing a commercial challenge from scaling up things, but that's why we are picking things where, for example, as I mentioned, there are some of the additional and pharmaceutical use cases, but we're talking about kilograms per year that we can use our current facility to. It's a little bit more about some regulatory compliance things, but that's also solvable, and therefore it's not needed. It's not needed to have like tens of millions and hundreds of millions invested. So where we are not just cheaper from that perspective, we can also reuse a lot of the cost by being a platform that then makes a nutraceutical with a pharmaceutical potential. When we make the next natural product, a lot of the work that have gone into the first might actually coexist, at least from an infrastructure perspective, from an knowledge perspective, from QC tools and other things we're building around it. So it's that ability to double dip in cost you have already had is why we can do it cheaper. Then it's just fundamentally faster and more engineerable, because nothing is alive, nothing is out of our control. If something breaks down, we can measure on it. We know exactly where the breakdown is. So it's almost like mechanical from the perspective where the other thing is literally living matter, but with its own will. So that's why it's cheaper. And then all of that aside, another perspective is we raised $15 million because that was a good amount for us to get to the next value inflection point. So where were we as a company? And how do we get to the next value inflection point so that we can have a conversation about raising more money or do something with those business opportunities we will be creating? And that is you can argue the experienced entrepreneur's perspective on the world, where instead of talking about I can do this, I can do this, I can do this, and you hear these popcorn brains worth of enjoyment of like, oh, we can do everything. I am looking for platform companies, but I get like super focused. How do we get to this value inflection point? With that end in mind, how do we break down to the steps we need to take to get there? And that is what we're spending our time and focus on. And if we can do that for a certain amount of money, raising more money than that just means unnecessary dilution. And frankly, often risk, because if we start having extra money, then we start being like, we can also do this other thing. And if it's not on the critical path up to that value inflection point, that's probably how we end up killing ourselves. So having that focus, then there's the other aspect of, you can obviously always kind of like gear that value inflection point to how big it's going to be. And there is maybe different than a lot of other biotech entrepreneurs, and maybe it comes from my culture. We're not trying to fake it till we make it. We're not trying to just make it big and then they'll come. It's much more of a like, how can we risk assess that journey? Because we absolutely want to get there. Because remember, my worldview is like, none of this matters. My time, my life would be wasted until it works for real. So it is a reality conversation and check. And there was just elements of like, we don't need that much money. It is probably the worst year in man's memory to raise biotech money on the stock exchange. So why did we do an IPO anyway? Well, because now we actually are a public company, and it gives us some completely new and freer tools to raise money than if you were caught up in the VC game, where you probably don't even have control over your own company after having taken the first money. But even if you think you have control over it, it's like you have been put in a swim lane that takes you down a path that will not allow you to take advantage of the different opportunities that does exist in the public reality, the public capital markets.
Yeah, and another point to consider as well is that eXoZymes will achieve revenue through certain partnership deal structures. So whether that be, spin-outs, joint ventures, or down the line, licensing agreements. And I'll be speaking with Damien Perryman, the Chief Commercial Officer of eXoZymes. And that will be also a part of the interview series, which I'm very looking forward to be releasing. So to that aspect, what state is eXoZymes platform currently in? Is it something that can be rolled out in the immediate future, or is it still something that needs 2 to 3 years of development and then can be rolled out? Or
it's a really good question, and it's going to take a little unpacking for us to get it right. Or I can just answer, well, it depends on, and then it's not really an answer. So depending on what it is we want to bring to market, we are in between already there up to there's still lots of things to work on. So the way we commercialize our platform with the focus we have talked about a lot today, nutraceuticals with the pharmaceutical potential, is to hit these points where something creates value. Value creation is either revenue, that is relatively easy to measure because it's like someone giving up his dollars from his bank account to my bank account versus I'm giving him something. Value creation have happened. A little bit harder to precisely measure is basically when you build an asset. There has been an asset built up, and that's an asset that is now tangible enough that it can be either exited or at least valued on its own. And it's the second commercial tool we're using. So we are talking with partners about creating an asset. So not ready for revenue generation, but ready enough to either be, I'm not saying we have anything to be sold right now, but like that could in principle be put a value on and like, James, you buy it from me. How much are you willing to pay for this opportunity? I will, because I have the platform, the only platform that can do this. I can give you exclusivity in the specific market of your dreams, the specific compound of your choice, and how much are you willing to buy that? We're not selling anything like that, at least yet, but we are starting and are in deep conversations about, for example, joint ventures, where we say like, wow, this is such a good opportunity. The competitive advantage that our new platform allows for in this market is kind of out of scale. So we don't want to just sell it. Then you can step into a licensing agreement, how much of that value creation will fall back to us. You can step even closer to us and say like, you know what, why don't we own half or some percentage part of it in a joint venture? You get part, I get part. You're the one that is the expert to go out to that specific market with this gun to a knife fight opportunity that I'm providing the gun for. But what is the fair joint venture setup there? And then there is, because we basically want to eat our own medicine, so to say. Don't take me too literal on that one, because we do make medicines here. We don't eat any of our own medicine. But when we spin out a company that is fully owned by ourselves, it's because we're looking at the business opportunity and going like, wow, that thing we're literally not ready yet to give up ownership, even in percentages. Because the asset buildup, we can see our way through these value inflection points to that even giving up 10% or 25% of trusted business opportunity right now would literally be what we just need to do the next value inflection point. Then it will be recognized at a much higher valuation. So those are our tools to do these things, and where we are in that portfolio of fully owned assets, joint ventures, and licensing. That's obviously where it, as much as I would love bringing you breaking news, that's not possible, because we are a publicly traded company, and I will let all shareholders have equal access to information in the right order. And when that's said, I can still in meta language tell you that as we have basically been communicating before, we after the IPO, that was what we really started focusing on, because IPO took time itself, on taking these technical solutions and finding the exact right technical competitive advantages we could provide, and then figuring out what are the right business models to commercialize via, and basically what should go first, because we are still a small company. We can't just go out and put on like 25 different projects, because again, boiling or trying to drink the ocean never works. So what do we go first with? And we are gonna give some guidance later this year on these things, and we are also gonna go out and announce these things. So it will be. I'll be happy to come back on your interview podcast series here and talk about those specific opportunities, because they are actually the ones that gets me like crazy excited. Because it's not about just building technology for the sake of technology. It's about making this impact on the world. And that is where, when we spin out either a fully owned subsidiary or joint venture, it gets very, very concrete. And frankly, also my job gets so much easier, because the questions like, what is you doing again? That we have now spent the most of an hour, if not more, on, actually turns into conversations about wow, you guys are the ones that makes this thing that can do this thing, and this is amazing because of this. And then when people have kind of understood that, and they go like, what do you mean with it's powered by eXoZymes? And then taking a step back in the whole new universe of like, wow, this can be done again and again and again.
Mm. And that's pretty prolific. And I think that, once the first few deals come onto the table, it will shed some light to the significance of eXoZymes platform and what the company can achieve. And I'm really looking forward to when they occur. So we're coming close to an hour here. So to wrap up, why should investors pay attention to eXoZymes?
It's pretty simple and complex. And it's the same thing when people ask me for guidance. It's like, oh, you stock cheap or expensive right now. I don't I can't give direct guidance on that. But what I can say is that if people sit down and close their eyes and think about where we will be, where they think we will be in 10 years from now or 5 years from now, and they then compare to where we are, then it's a risk calculation on if we're the right team, if we have the right technology, and there's no doubt that we are not the steady going, just wait for some dividends to come out kind of investment. If that's what you're looking for, we are not your gas. If you're on the other hand looking for a team that is taking a very, very large bet on finding a new generation of biosolutions, then I have not found anyone that is even close to being as ambitious and as realistic as we are.
Yeah, I mean, what a great way to finish off, Michael. And thank you so much for jumping on and speaking with me about the company. I'd just like to remind listeners to head over to Slack Capital, read my report, and also listen to the other videos in the interview series that will be released very shortly. But, as a long-term shareholder, I can clearly see the impacts that eXoZymes platform will have. And I'm very, very excited about the coming future. But yeah, thank you so much again.
I agree, and thank you very much.